What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we are going to be going over our camera, so converting it from blueprints to code yet again. In this episode, we'll be going over converting something from our 3D mini-series, and when we have that, we need 3D boundaries. We had a function in the camera to set up these 3D boundaries. We want to convert that function from blueprints to code. And then we're also going to make some of the hard-coded or magic numbers variables. That way we can customize them and be more professional about our camera code. Now, before we hop into this episode, if you want to get caught up into the entire fighting game tutorial series, so you see how we can do things like combos, hitboxes, throws, and lots of other fun stuff, you can check out this link in the top right corner. This is the entire fighting game tutorial series on YouTube, so you can see how many episodes we've done, all the content we've made. If you only care about the C++ fighting game camera, that's perfectly fine. You don't have to watch the entire series to implement that, but I do recommend you start from the first camera episode, which I'll link right here in the top right corner. If you follow the camera episodes, then you'll be able to see and get what we have here on your side in your game. With all that out of the way, we can go ahead and get started. This is a code and blueprint tutorial series. Again, we're converting blueprints to code, so we're going to be working pretty evenly today. So we're going to be filling out our last function that we have not added in the code. Technically, we still have the freeze camera and resume camera events that aren't finalized in code because we don't have a super camera in code, so we can't do that part in the code just yet. But we do have the functions written. The one function that we don't have written so far is the set 3D boundary, so we're going to do that right now. Let's go to our base camera.h class, and very similar to where we have calculate inner boundaries and calculate outer boundaries, I also want to calculate the forward and backward boundaries if we're doing our 3D fighter. So the 3D fighter is a series, a little mini series, that's using my fighting game template here, but also making it work similar to Tekken, Virtual Fighter, that sort of thing. So we have that three-dimensional movement where it's not just left and right across the screen, but also back and forth. And because of that, we needed 3D boundaries. So I need to make a function for this as well. So I'll go ahead and make a new one here. Determine the locations for the front and back boundaries and assign them. U function, blueprint callable, in case we want to call it from the blueprint. Void calculate 3D boundaries. Then we go to base camera.cpp and we scroll down here. Void a base camera, calculate 3D boundaries. Now we'll have to look at the blueprint to figure out what we need to do in here. Now I'm actually watching the logic of this function from my video that I made instead of in the blueprint editor because I've already removed these and I can't record it. So I had to just look at it on here. So I just improved the quality, but it's going to be very simple for us to transfer this over. Basically, we have our player one reference and we're getting the location. The only location we care about in this case is the x-axis location of the players because we know that wherever they are at the starting point is going to be in bounds. And so from there, we can figure out where we want our front and back boundaries to be placed. I have this front max and back max variable as well that you'll see in here. And we already have our front outer edge and back outer edge too. In here, you can see we use player one reference, get actor location, and modify the x value. Let's mimic this. So the way we've been handling our player references in our camera is by grabbing the game mode. So we can do these two lines just like we do in a lot of our functions. So if auto base game mode equals cast a fighter template game mode. And the thing we're casting is going to be get world, get auth game mode. Get the world to get the game mode that's being used, cast it to make sure it's the fighter template game mode because that is what has our player 1 and player 2 references, and set it equal to this variable. It's all put within an if statement because only if it's true and we have a valid game mode do we want to do anything on it. Then we want to make sure that player 1 is true because we are using them for location reasons, knowing where we want to put the camera boundaries since they are relative to the player. So if base game mode active team 1 character. Basically, if our first character is valid, then we can use them to place these boundaries. Back in the video now, you can see that we were using their X location, and we were technically subtracting 700 from it to get our front max because negative on the X-axis is forward. so we're getting closer to the camera. So we were taking the actor's location on the X, subtracting 700, setting it to front max, and then we were going to move the front outer edge to this new location. I also updated the rotation and scale to match what I know to be true for all of our setups and our levels, but we'll get into that in a second. We want to set front max equal to base game mode, active team 1 character, get actor location, .x. But remember, we were subtracting 700 as an arbitrary value. We'll make this into a variable later. So this is our front max, and we want to set our front outer edge to that place. But also we can actually cover the back max here, like we did in some of our other functions, how we calculated left max and right max first, and then determine where to place the camera edges. So I'm going to do that one as well. I know this one from memory. So back max equals base game mode, active team 1 character, get actor location .x plus 700.0f. And we can also see it here in the video. I will show you I have player 1 reference, and I'm using my get actor location, and I'm adding 700 here, and then setting back max to that value. And then afterward, we are of course going to set the back outer edge to that new location, rotation, and scale. So we have these two set up. Now we need to set these edges. Front outer edge, set actor transform. Transforms take a location, rotation, and scale, so we need to make location first, which is an F vector. And specifically for this, we are going to use new F vector. We're going to use front max, comma, and then we can use active team 1 character. Dot get actor location. Dot Y. Then we're going to do the same thing if we copy this here, but do .z. Okay, and you can see it right over there. If you want, like a lot of our other functions in this class, you can update this so that it looks like this, if that's easier for you. That way it doesn't have to go off the screen. But after the F vector, we have to make an F rotator as well. So it's going to get pretty ugly pretty quickly. F rotator. This one is pretty simple. We can do 0.0f, 0.0f, and 90.0f because that's what we were doing in the blueprint. Last one we need is an F vector again. F vector. This one's our scale, and we had 1.0f, 10.0f, 1.0f. And you can see it here in the video for both front outer edge and back outer edge. It looks like this. Now when you do this, you're going to get an error on F transform, and that's because you actually have to put the F rotator first. I forgot that one because I was looking at it in the blueprint. And honestly, location, rotation, and scale, they usually go in that order, but it's true in F transform, rotation is the first parameter. So apologies for that. I'm going to take out the F vector and move the F rotator in its spot. After the comma of F rotator, I'm going to put my F vector for my location. And it will look something like that, as ugly as that is. So we have F rotator, F vector for our location, and F vector for the scale. Now we want to do this thing for the back outer edge as well. But this time we don't want to use front max, we want to use back max. The other stats are actually exactly the same, so you don't have to change any of them. Now we can also assign values to these variables so that they're not hard-coded numbers, such as the offset for the boundaries, the correct rotation, and the correct scale. So if we go back into base camera.h, we can scroll down to our variables here, and we're going to want an inner default, just like we have the outer default, which is going to be the essential offset that we have at the start of the match for our inner boundaries where they're initially placed. So we're going to go in here and make this a U property of blueprint read write and edit anywhere. And we're going to call the variable float inner default. Then we're going to go back into base camera.cpp in the constructor and set this to the default value, which we know is 200 because we set this up earlier in calculate inner boundaries a few episodes ago. Once we set it to 200.0f, we can replace it in calculate inner boundaries right here, where we're setting the inner boundaries for left and right locations. And instead of adding or subtracting 200, we're going to add and subtract inner default. And we can add one for the front and back default offset as well. So same U property as before, edit anywhere with blueprint read write, and we're going to call this one float depth default for front and back default. We're going to set the default value for this to be 700 because that's what we set it to in calculate 3D boundaries. And we're going to replace our 700 offsets here with our variable. After this variable, we can also go back and add one for the minimum distance between our players before the camera boundaries move. So if they're too close, we're not going to move the inner boundaries. We don't need to. If they get farther away, then we will need to. So this is the minimum distance between the characters before we have to move those inner boundaries. Same deal here, same U property, edit anywhere, blueprint read write. We can go over to the constructor, set the default value, which is also 700 just by coincidence. And we will replace this in calculate inner boundaries. I hope you enjoyed this episode of converting your camera and converting the set 3D boundaries from blueprint to code. If you did, please subscribe and consider joining the Patreon, YouTube membership, or Discord subscriptions to support me further. Thank you guys so much for all the love and support. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description, and I would be happy to help you out with any problems you ran into. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.